Section 5.5 is about solving rational equations. So first let's define what a rational equation is. Equations have equal signs as opposed to rational expressions that we covered before. And we can clear these fractions as we did in section 1.1. So a rational or fraction equation is an equation containing one or more rational expressions. And here's some examples. Again, we have rational expressions on the left and on the right of the equal sign. And so the objective is to find the value or the values for x and make that a true statement. We will go over several examples. The basic idea is this: to solve a rational equation, the first step is to clear the equation of fractions. And to do this, we multiply all terms on both sides of the equation by the LCM of all the denominators. Then we carry out the equation solving process as we had discussed in chapters 1 and 4. So again, the key is to multiply both sides of the equation by the LCM, and that'll get rid of all the fractions. In the first example, the LCM is equal to 10. So multiplying both sides by 10 gives us 10 times y minus 4 divided by 5 minus y plus 7 divided by 2 equals 10 times 5. So it's important to remember to multiply the right-hand side by 10 also. So then we have 10 times y minus 4 divided by 5 minus 10 times y plus 7 divided by 2 equals 50. The 5 goes into 10 2 times, and the 2 goes into 10 5 times. Using the distributive property, 2 times y is 2y, and 2 times minus 4 is minus 8, and minus 5 times y is minus 5y, and minus 5 times 7 is minus 35, and that's equal to 50. And collecting like terms, 2y minus 5y is minus 3y, and minus 8 minus 35 is minus 43. We add them to both sides, so then 43 and 50 is 93. Divided by minus 3, then y is equal to minus 31. So once we have the equation in this form, it looks a lot like we've done it in previous chapters, and we simply isolate the variable. When solving rational equations, it's always a good idea to check your answer. I would do it in this case. In the future, I leave it up to you. But when we replace y with minus 31, we get the following. Check. For the first expression, we get minus 31 minus 4 divided by 5 minus 31 plus 7 divided by 2. So that means minus 35 divided by 5, that's negative 7. And minus 31 plus 7 is minus 24. And minus 24 divided by 2 is minus 12, but the minus sign would be plus 12. And that's equal to 5, as it should be equal to 5. So that checks, and the answer is correct. The next example is a guided solution. Here we have the equation 2/3 plus 5/6 equals 1 divided by x. So our least common multiple is 6x, or 2 times 3 times x. So we multiply both sides by 2 times 3 times x. So 2 times 3 times x times 1 over x. So it's 2 times 3 times x times 2/3, plus 2 times 3 times x times 5, 6 equals 2 times 3 times x times 1 over x. So then the 3's cancel, and so that means we only have 2x times 2, and then here we have the 2 times 3 cancelled against the 6, so that's 5x, so x times 5, and here the x's cancel, so we have 2 times 3. Therefore, we have 4x plus 5x is 9x equals 6. Dividing both sides by 9 gives us 6 divided by 9, or we can reduce that to 2/3. And by the way, that checks and is the solution. For the next example, we look at the denominators of the rational equation here, and they are x plus 5, and x squared plus 5x. So when we factor the denominator here, we get x times x plus 5. So that would be our LCM. And when we multiply each term by the LCM, we multiply each numerator by x times x plus 5. So in other words, 4x times x plus 5 divided by x plus 5 plus 20 times x plus 5 divided by x equals 100 times x plus 5 divided by x plus 5, which is the factored form of the denominator here. Now we can cancel these factors here, and we have 4x squared. And we can cancel the x against the x, and then it gives us 20x. 20 times x is 20x, and 20 times 5 is 100. And here we cancel the x against the x plus 5 against x plus 5, so that's equal to 100. Now we subtract 100 on both sides, and that gives us 4x squared plus 20x equals 0. We can now factor out the greatest common factor, which is 4x. 4x times x plus 5 equals 0. Now we apply the zero product property. That means we set each factor equal to 0. And when we set 4x equal to 0, that means that x equals 0. So that's one solution. When we set the other factor equal to 0, x plus 5 equals 0, that means x equals negative 5. Now, ordinarily we would think, okay, we are done now, we found the two solutions. But as I mentioned a moment ago, it's really important to check your answers and by substituting them back into the original rational equation. So our answers are x equals 0 and x equals negative 5. Okay, so let's substitute x equals 0 into this original equation. And you notice right away, when x equals 0, we have an undefined expression. So what that means is that x equals 0 is not a solution. Okay. Now, when we use x equals minus 5, in this first expression, then minus 5 plus 5 is 0. So that creates a 0 in the denominator. Again, we have an undefined expression, which tells us that x minus 5 is not a solution either. So, in answer to the question, this rational equation has no solution. This should not come too much of a surprise, because when we had very simple equations, there were occasions when we had no solutions as well. So let me explain here on the margin here. When you have an equation x equals x plus 3, that equation has no solution among the real numbers, because when we subtract x on both sides, then we get 0 equals 0 plus 3, or 0 equals 3, which is certainly false. So that indicates that this equation has no solution. So occasionally it happens that rational equations have no solution, like here, even though it looked like we had two solutions. Or they may have one solution, or they may have two solutions. So it all depends. So that's why it's critical that when you have a solution, quote unquote, that you always check it in the original equation to see if it's a solution that really works. In this case, none of the answers supplied a valid statement. We had undefined expressions for x equals 0 and x equals minus 5, so the conclusion is there's no solution to this rational equation. Let's look at the next exercise here. So obviously the least common multiple is x minus 3. And so we multiply both sides of the equation by x minus 3. We get the following. We get x squared times x minus 3 divided by x minus 3 equals 9 times x minus 3 divided by x minus 3. So the LCM is x minus 3. Okay, so now we can cancel the x minus 3's. So x squared equals 9, or x squared minus 9 is 0. So in other words, we can now factor x squared minus 9 into x plus 3 times x minus 3 and set each factor equal to 0. When we set the first factor equal to 0, we get x plus 3 equals 0, or x equals negative 3. And when we set the second factor equal to 0, x minus 3 equals 0, then x equals 3. So again, we have two solutions, and what we need to do is we need to substitute these solutions, or what we think are solutions, into the original rational equation. So when we substitute x equals 3 in the original rational equation, we get x, so x equals 3. We get x, or 3 squared divided by 3 minus 3 equals 9 divided by 3 minus 3. In other words, we have 0 in the denominator, so 9 divided by 0 equals 9 divided by 0. And these are undefined expressions, so x equals 3 is not a solution. When we replace the variable with x equals minus 3, let's see what we get. Then we have x squared, so it would be minus 3 squared divided by minus 3 equals 9 divided by minus 3, so we have 9 divided by minus 6, and that's also equal to 9 divided by minus 6, and so that's equal. So the only solution we have here is x equals negative 3. So x equals negative 3 is a solution. So in this case, we only had one solution, this one here. The other one is not a solution. In the next exercise, when we look at the denominators, we know we can factor x squared minus 9 into x plus 3 times x minus 3. And those are the other two factors, the other two denominators here, so that's our LCM here, x plus 3 times x minus 3. So, to clear the fractions, we multiply each expression by the LCM in the numerator. So we get 2 times x plus 3 times x minus 3 divided by x squared minus 9, and again that's x plus 3 times x minus 3. And then for the second term, we have 5 times x plus 3 times x minus 3 divided by x minus 3 equals 3 times x plus 3 times x minus 3 divided by x plus 3. So now we're going to cancel the denominators. So we have a 2. And here we cancel the x minus 3. And then we have 5 times x plus 3, which is 5x. And plus 5 times 3 is 15. And on the right side, we can cancel the x plus 3 against the x plus 3, and we have 3x minus 9. And this is simply a very, it's a linear equation, one variable in x. So when we collect like terms, we have 5x plus 17 equals 3x minus 9. So we subtract 3x on both sides, we get 2x. And when we subtract 17 on both sides, we get minus 26. And we divide by both sides by 2, so x equals minus 13. And you can check minus 13 in the original equation, and you find out that that's a solution that works. So x equals minus 13. Last, let's look at the following statement. Given that f of x equals x minus 12 divided by x, find all values of x for which f of x equals 1. So in other words, we are looking for an expression x minus 12 divided by x equals 1. So when we multiply both sides by the LCM, which is obviously x, then we get x times x is x squared, and minus 12 times x divided by x is minus 12, and 1 times x is equal to x. So then we subtract x on both sides, and we are looking at the quadratic equation x squared minus x minus 12 equals 0. So we can factor the trinomial x squared minus x into x minus 4 times x plus 3 equals 0. And when we set each factor equal to 0, when we set each factor equal to 0, x plus 3 equals 0, then x equals negative 3. And we set the other factor equal to 0, then x minus 4 equals 0, or x equals 4. So these then are our two solutions to this question here. So for x equals minus 3 and x equals 4, this condition will be satisfied for these two values of x. And this concludes section 5.5.